Hello everyone, today I would like to talk to you about numerical integration using four different methods. First one is trapezoidal rule, second is Romberg integration, third is Simpson's 1/3 rule, and last, Simpson's 1/3/8 rule. So, the very first step we have to do is to get the n or h of each one. So, we have a function of x raised to the fifth minus 3 times x raised to the fourth plus 3 times x raised to the third minus 2x squared plus 2x with the upper limit of 3 and a lower limit of 1. So the first thing we have to do, we're now given n, which is the strips or the number of cuts. So I have 1 strip or 1 cut, 2 cut, 4 cut, and 8 cut. And we have 7 cut because we will have to use that later on as an example. Okay, so first of all, we have to get our h. In order to get our h, we have to subtract the upper limit minus the lower limit and then divide it by the number of n, which is the number of strips or number of halves. Okay, so we do this all throughout the n's. So here n2, n4, and then n8. Okay. And then afterwards, what you can do is your h, you're gonna add that up starting from 1. But since 1 plus 2 is equal to 3, so you'll get 1 to 3 there. And to find f of x, you need to input the x values into our numerical integration function. This one, to get 1, and then to get 96. The same goes for the rest. So you have 1. Since your h is 1, you start from 1, you add 1. So 1 plus 1 is 2. 2 plus 1 is 3. You input 2 into this limit or function, so you get 4. Okay, last one I want to use as an example is this one. Okay, so your h is the interval between 1 to 3. So you have 1 plus 0.5 will give you 1.5, plus 0.5 again will give you 2, plus 0.5 will give you 2.5, and plus 0.5 will give you 3. Input that into the calculator, you'll get these values. So moving on, we're going to trapezoidal rule now. So this is the formula that we will use. It's h over 2 times y initial plus 2y middle plus y final. I'll explain that to you in a minute. So we will use, the best example we can use is n equals 4. So using n equals 4, we have this. Okay, so our h is 0.5 divided by 2, okay, times L8, which is our y initial, 1, plus 2 times all the middle ones. So we have 1.03125 plus 4 plus 19.8438 parenthesis. That's your y middle plus the y final. After that, press enter so you get the values. There you go. Okay, so what this means is the bigger your strip, the more accurate your area is with the exact one. This is your exact. Okay, moving on. We're now using Romberg's integration. So using Romberg's integration, we are given this formula. 4 raised to n times I sub 2 minus I sub 1 all over 4 raised to n minus 1. What this means is we have to get the I sub 1 and I sub 2, I sub 4, and I sub 8 meaning this is the values of the I sub 1, I sub 2, I sub 4, and I sub 8 is your I sub 2 and I sub 1. So, okay, let's use an example. Right here. See this? So, I have my 4. 4 raised to 1. The n meaning is the order. We're finding the third extrapolation, which is the third order, and n equals 3. So now we have the first order, n equals 1. So 4, it's just 4. And then I2 times I2 minus I1 all over 4 minus 1, which will give us this value. And then we do the same with I4 and I2. So our I4 is going to be our I2, and then our I2 is going to be our I1. And then same goes for this one. And then you do that all over again for the second order, but this time you're going to have to change the n in the 4 to 2. Yeah, here you go, 2, and then 2. And continue doing that until you've reached the third order, which will give you the final Romberg integration. Moving on, we have the Simpson's 1/3 rule. Simpson's 1/3 rule is easy to use and very simple. Okay, so this is our formula. H over 3 times y initial plus 4 y even plus 2 odd plus y final. Okay, so this formula, h over 3 times y initial plus 4 times the even values, which is 2 here, 2, 4, 6, and then 8. And after that, plus 2 times the odd numbers, which will give us 3, 5, 7. You're not going to include 1 and 9 because they are the initial and the final value. Okay. And then the last one is the final value. There you can get the Simpson's 1/3 rule value. And then the last one is the Simpson's 3/8 rule. It's basically the same with the Simpson's rule, but with Simpson's 1/3 rule, you could only use Simpson's 1/3 rule if you have an even number of strips. In Simpson's 3/8 rule, you're gonna have to use it if you have odd strips, meaning you can only use this if it's 3, 5, 7, 9, and so on, odd values. So first thing we have to do is okay, so now we use the number 7, using n strips of 7 right here. Okay, so using this formula, we input now the value, but it's only just, we're gonna use the first 3 strips. So you have 1 strip, 2 strip, 3 strip. Okay, so using this formula, your h is given here. Okay, and then your 1 initial plus 3, because it's given here, 3, and then the middle values, which is this one and this one, plus the final value. Okay, so that's your Simpson's 3/8 rule, which will give you that value. And then after that, we're gonna use Simpson's 1/3 rule for the remaining strips, which is 4 strips, 1, 2, 3, and then 4. Okay, so same as the previous example, we're gonna use the same h, but you need to number the values so you won't get this, so you won't make a mistake. So starting from where you left off, so you have 1 here, 2, 3, 4, and 5, because the values, if you choose these values, you're gonna get the wrong answers. So here you have your h, and then the initial plus 4 even, which is your 2, and then your 4, plus 2, which is your, and then plus 2 times your odd value, which is 3, and then plus the final. And afterwards, you're gonna add them both up, and then you're gonna get the total area. Okay, thank you.